Hey, so today we'll be going over Pre-Calc 112 mock exam 3. Alright, let's start with the first question. Okay, so for the first question, they're asking us to sketch and graph sine of x over 2. Okay, for this question, we're going to use two things. One, the normal graph of sine, which looks like this, which has a period of 2 pi. Two, we're using the generic formula of sine, which says a sine of bx plus c plus d. A is the amplitude, b helps us find the period, c helps us find the phase shift, and d helps us find the vertical shift. Okay, so this is the normal graph for sine of x. Let's see what the differences between sine of x and sine of x over 2 are. The difference is that sine of x over 2 has an extra b in it. B does not equal to 1. Therefore, b equals to 1/2. So we want to use the fact that b equals to 1/2 to find the period. We know that the period equals to 2 pi over b. So in this case, the period would just equal to 2 pi over 1 over 4 and over 1 over 2, I mean. And this would just equal to 4 pi. Therefore, the period and the only difference between sine of x over 2 and sine of x is the fact that the period in sine of x over 2 is 4 pi, while it is 2 pi in the normal sine. Okay, let's just graph it real quick. Okay, the normal graph is going to look the exact same thing, but it's going to have a different period. So instead of having 2 pi, we will have 4 pi here. And to find what this point is, what this point is, and what this point is, we can just do 4 pi over 4, and this would equal to pi. Therefore, this point is pi, this point is 2 pi, this point is 3 pi, and we know that this point is 4 pi. The amplitude is still going to be 1, so it's going to go from 1 to -1, and that's it. Here's how the actual graph would look like using Desmos. Okay, now let's move into the next question. Question 2. Question 2 is asking us to graph 2 times 10 to the -3x. Okay. Alright, first we're going to use two facts. Number one, the graph of any number times x. For example, let's do 3 raised to an x would just look like this. It would go from -infinity to infinity, and it would always pass through the point 0, 1. But if we multiply 3x by 2, for example, so let's say we're doing the graph of 2 times 3x, 3 to the x, then the graph would simply just would look the exact same thing, and it would just go through the point 0, 2. And if we flip the sign of x, if we make it 3 to the -x, then the graph is just going to flip around. For example, if we're doing 2 times 3 to the negative x, graph would just be like this. I'm sorry, because okay, the graph would just look like this, and it would still go through the point 0, 2. Okay, hope this is making some sense so far. Okay, so let's use these facts to graph the thing we're asked to actually graph. So 2 times 10 to the negative 3 x. Okay, let's first draw the axes. Okay, we know it's 2 times this number, which means that the graph is going to pass through the point 0, 2. So let's make a dot over here with 0, 2. It's times 10, so it's going to be pretty steep. But we see that there's a negative 3x, which means that the graph is going to look something like this. It's negative, so it's going to go the other way, which is from infinity to negative infinity in some sense. And it's going to be much steeper than the graphs we drew before because there's a 3 over here. Alright, let me show you how the exact graph looks like using Desmos. Mine isn't drawn exactly to scale, but you can see it's the same general shape. So this goes up until it goes to infinity, and it's much closer to the x-axis because we have a 3, but it still goes through the point 0, 2, as we said before. Okay. The third question. Okay, third question is saying 20 cosine of 2x minus pi over 2. We're going to use the same two facts we used for sine, but for this time it's going to be for cosine. Okay, that's number one. We know that the graph of cosine of x looks something like this. It has a period of 2 pi and passes the y-axis at y equals to 1. Okay, and it has the general formula of a cosine of bx plus c plus d. Okay, so let's use these facts to find how the graph of 20 cosine of 2x minus pi over 2 is going to look like. First, we see that a equals to 20, so the amplitude is just 20. Second, we see that there's a 2 where b is, so let's find the period. So the period would just equal 2 pi over b, and in this case it's 2 pi over 2, which just equals to pi. Okay. The third thing we see is that there's a phase shift because we have 2x minus pi over 2, but the phase shift isn't just c, which means that the phase shift in this case does not equal to pi over 2 or negative pi over 2. To find the phase shift, we write the whole equation that's inside the parentheses, which is just 2x minus pi over 2, and then we solve it for x, so we set this equal to 0, which means that the phase shift is going to be 2x equals to pi over 2, and then when we divide by 2 we get x equals to pi over 4. Okay, the fact that we got pi over 4 tells us two things. Number one is the graph is going to be shifted to the right by pi over 4. Two, oh, there's no two, it's just one. I was planning on breaking it into two pieces, but I already said shifts to the right by pi over 4, so it's just one fact. Okay, now let's use everything we know to graph this. number 1. We know that the amplitude is going to be 20, so it goes up from 20 to -20. Number 2, we know that the period is pi. So let's set pi somewhere in here. And we know that it's going to be shifted right by pi over 4. Okay, let's use the cosine graph for a reference. Okay, graphing this to exact scale isn't going to be easy, but I'll do my best. Alright, so let's see how this goes. Shift it to the right by pi over 4, so it should look something like this. And then from peak to peak, we will have pi. Okay, I didn't really draw this anywhere near scale, but 20 should be over here, and I'll show you the exact graph from Desmos in a second. This should give you a sense of how it should be drawn. So from peak to peak, we should have pi as our um, period, and then to find what this point, and all the other points are going to be, we just do pi divided by 4, so this would just equal to pi over 4, which means that we start with pi over 4 somewhere in here, but it's not going to be just pi over 4, it's going to be pi over 4 plus pi over 4, because we shifted the whole graph by pi over 4, which also means that I already did a mistake, and I'll give you a minute to try and figure out what the mistake I did. It's already in the graph, so try figure that out, and then I'll show you what the mistake is in like 1 second. I'll give you a couple of seconds. Okay. So we said that the graph is shifted by pi over 4 to the right, and we know that the period is pi over 4. But that would mean that when the period is pi, it's going to be pi plus pi over 4, because we already shifted the graph by pi, and that's the mistake that I was trying to let you figure out. So this would just be 2 pi over, so pi plus pi over 4 would just be 4 pi plus pi over 4 would just equal to 5 pi over 4. Okay, and then to figure out what these points are, we do pi divided by 4, we get pi over 4, and then we just keep adding pi over 4 to that to get this point, and this point. Alright, let's start. I'll just show you the graph to make it a bit easier. Alright, here's the graph. By looking at this, we see that the period is actually pi over 4, and the amplitude is 20, and that's mainly it. Alright, we move into the next question now.